So this is a quick video about isotopes and some of their special properties, and we're going to talk a little bit about decay. So this is continuing on from what you did on atoms, ions, and isotopes worksheet 1. Okay, so isotopes, to review, it is the different atoms of an element with a different number of neutrons. So it's still the element, right? So it is the same chemical makeup because it's the same element. Okay, that says makeup. It definitely doesn't look like it says makeup. But a different mass. Because of course we know that in the nucleus is the protons and the neutrons, and then the electrons are outside. And we'll get into that much more later, especially in the next chapter. A quick note here that electrons are way, way, way smaller than protons or neutrons. Okay, their mass is practically negligible compared to that of a proton or a neutron. So most of the mass is in the nucleus. Okay, so an isotope is not something that's different from an atom. It's just the term we use to describe two atoms, same element, but the neutrons are different. So their mass is going to be different. Okay, and that's what you were doing in the atomic mass packet, is looking at different isotopes of an element, and you were given the masses for each isotope, and they're all different because they all have a different number of neutrons. Okay, so you've done all of that. Okay, so some isotopes, let's change color here. Some isotopes are unstable. Now, that's a very general term. I mean, unstable can use a lot of things. In this case, we are talking about isotopes that are radioactive. Okay. So basically what happens if the ratio of protons to neutrons is, I'm going to say very uneven in quotes, then the isotope is unstable. So I put that in quotes because there's no like definite number, like, oh, once you have this many more neutrons, then it's automatically unstable. It doesn't really work like that. Okay, but the closer the ratio of proton to neutrons is to 1, the more stable it's going to be. Okay? So let me tell you something about isotopes. They're kind of like people, right? You know, in this day and age, okay, things are very stressful, right? So you have this little isotope, its life is kind of feeling like it's out of whack, you know, it can't sleep at night, drinking lots of coffee, you know, and it's getting more and more upset, you know, it's not getting along with its friends, it had a fight with its mom last night, it has to work, you know, there's so much work, you know, hybrid in person, and these isotopes are just, their feelings just sort of, they build up and they build up until they just can't take it anymore. And then they shoot out a particle. Yeah, that's what happens. So if only we could just shoot out a particle and feel better during this stressful time. Okay, so we say that they decay, that's the word, by giving off alpha and beta particles. So let's take a look at those. So alpha emission, and the symbol for alpha looks like a little fish. Okay, so this is alpha emission. And an alpha particle is made up of 2 protons and 2 neutrons. Now, I'm very disappointed that I'm not actually doing this in person in class, because at this point, I would say over and over, 2 protons, 2 neutrons. And then I'd call on people and ask them, how many protons? And people would say 2. And I'd say, that's right, 2. Not 1 proton, not 3 protons or 4, 2 protons and 2 neutrons. How many protons are there? That's right, 2. 2 protons. So what's an alpha particle? 2 protons, you say? Yes, that's true, 2 protons. What else is an alpha particle? Maybe take a look at your periodic table. 2 protons. Yep, 2 of them. That's true. You're looking at your periodic table? What's 2 protons? It's a helium nucleus. Okay? And usually I wait as long as it takes for somebody to figure that out. But this time I had to tell you. But I'm going to pretend that all of you figured it out before I said so. Because remember, the protons is what makes an element an element. Okay? If it only has 1 proton, then it's hydrogen. If it has 2 protons, it's helium. That's what makes it what it is. Okay, so an alpha particle is a helium nucleus. Okay, so let's look at an example. If I had this isotope of uranium, okay, because that's definitely radioactive, okay, and it's going to give off an alpha particle, what are we going to get? Remembering that it is 2 protons and 2 neutrons. So you're going to fill in the new isotope right here. Are you done? All right. So remember, the top number is the mass number, which is protons and neutrons. So since we have 2 of each, that's going to go down by 4, right? The bottom number is the atomic number, okay, which is just protons. So we have 2 protons, so that's going to go down by 2. And so now that it's number 90, it's not uranium anymore, because we just said the number of protons is what makes the element what it is. It's going to be thorium. Okay? All right, let's take a look at beta emission. Okay? Now beta, the symbol kind of looks like a swoopy bee. That's kind of how or maybe like a butterfly wing, however you want to think of it. Okay, so this is beta emission. Okay, now a beta particle completely different from an alpha particle. A beta particle is an electron shooting out of the nucleus. Yep, that's what it is. It's an electron that is shooting out of the nucleus. Anybody want to comment on that? Electron shooting out of the nucleus. Yeah. What is an electron doing in the nucleus? They don't belong there. Okay, so this is what happens in beta decay. Now, I'd like to tell you that I'm going to use my artistic license here. This is not exactly how it happens, but let's imagine our little neutron. There it is. Okay, so what happens in beta emission, and neutrons are in the nucleus, right, is it breaks down. And it leaves a proton and an electron in its place. Now, again, artistic license, neutrons are not actually like eggs. They don't hatch. But in a beta decay, a neutron does decay and it leaves a proton and electron in its place. Now, this is in the nucleus, right? So, proton looks around. He's like, hey, what's up? How you doing? Good to see you, right? Feels pretty comfortable. The electron looks around and is like, I'm the only electron in this place. Like, this isn't, I don't belong here. I have to get out of here. And then it leaves because, you know, it doesn't belong there. So whooshoo, right out of the nucleus. Okay, and that's your beta particle. Okay, so let's put this in, write down exactly what this is. So a neutron decays, leaving a proton and electron in its place. The proton stays, so now you have a new proton that you didn't have before. The electron leaves. Okay. Okay, so let's continue with thorium, right? So if we have 23190 and we go through a beta emission, okay, stop for a second and see if you can figure out what it would turn into. Okay, so we gained a proton. Okay, so that means we're going up to 91. Okay, which means that this is now protactinium, Pa. Okay, now what about the top? Remember, the top is protons and neutrons. So we gained a proton, but we lost a neutron. So that means the top is going to stay the same. Now, sometimes people ask, well, gee, shouldn't there be a charge because of electron? And this is nuclear chemistry right here. So these isotopes, when you write an isotope symbol like this, and doing these decay, we're just looking at what's going on in the nucleus, okay? Okay, so you get 23191 Pa, right? And both of these decays would be considered a transmutation, got a little vocab word there, which is the conversion of one element into another. Okay, so this is a really good example of how The number of protons makes the element. Like, for example, you might think at this top one up here, well, why is there a helium in the middle of uranium? It's not like that. As soon as those two protons are separated from the uranium, it's helium. That's just what it is. Okay? It's kind of like magic, right? I mean, again, this class is potions, so. Okay, so you are now going to do a worksheet because showing the decay series of a different isotope of uranium, uranium-238. Because specific isotopes have a series of decays, alphas and betas, that they go through every time. Okay, so that's what you're going to do next.